Good morning. Area of triangle. We have learned many ways to find the area of triangle. Like when we start with our basic method, if a triangle is mentioned with a base B and height H, then area of triangle is half BH. If the triangle is a right triangle with perpendicular sides are A and B, then the area of this triangle is half AB. If the triangle is an equilateral triangle with side A, then area is root 3 by 4 A square. If the triangle having the sides A, B and C, then area is under the root S of S minus A of S minus B of S minus C, where A, B and C are sides and S is the semi-perimeter. You have learned this one in grade 9 as Heron's formula. Okay, and there are many other formulae, like if we consider a triangle with the sides are A and B and this angle is theta, then area of this triangle is half AB sine theta. Okay, see, these all are different ways to find the area of triangle according to the situation. So we use these two formulae. When we know the base and height. And this is a specific formula we use for equilateral triangle. And we use this formula, Heron's formula, when we know all the three sides, the length of all the three sides. And this formula we use when two sides and the included angle is given. So this all formulae is according to the given situation. If so, if a triangle is in the given form A x1 y1, B x2 y2 and C x3 y3 are the three vertices. If the given informations are the three vertices, how do you find the area of triangle? So here we learn a new formula to find the area of triangle, which is area of triangle is equal to half x1 of y2 minus y3, x1 of y2 minus y3 plus x2. We're done with x1. Now we go for x2 of y3 minus y1 plus, now we go for x3 of y1 minus y2. So area of triangle is half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. Okay, this is the formula to find the area of triangle using the vertices. Its proof will be given in another video. Okay, and when we do the calculation by substituting here, what you need to do is remember the formula, replace the values. Okay, remember the formula and replace the values. We get a solution, an answer for the area. In a few cases you will get area as negative, but can the area be negative? No, because area is a quantity, it never be negative. Though we get a negative answer, we can convert it into positive by taking only its numerical value. Okay, for example, if your area is minus 5 square units, just consider it as 5 square units. Okay, let's do one example. Question is, find the area of the triangle formed by the vertices 1 minus 1, minus 4 6 and minus 3 minus 5. So before going to the formula, what we need to do is write the corresponding terms like x1. What is x1? 1, y1 minus 1, x2 minus 4 and y2 6. Similarly x3 minus 3 and y3 minus 5. Now go for the formula. Recall the formula in your mind. Area of triangle is equal to, start with half. And which variable we use first? Yes, see, we use x1 first. So that what we subtract the remaining two y's, y2 minus y3. Plus, next we use x2. So which are the variables we subtract? The remaining two. That is y3 minus y1. Don't do y1 minus y3, always from right to left. y3 minus y1 plus the last variable is x3. So what subtraction we do here? Yes, remaining 2, that is y1 minus y2. See here in the formula, 1 2 3 2 3 1 3 1 2. It is a cyclic formation. 1 2 3. In the first one we write 1 2 3. The second one we start from 2, so it will get 2 3 1. Yes, and the third one we start from 3, so we get 3 1 2. This type of expressions are known as cyclic expressions. Okay, so now let us replace the values. Half, replace carefully. x1 is 1 of y2 minus y3, that is 6 minus y3 is minus 5. So replace everything very carefully. Plus x2. What is x2? Minus 4 of y3 minus y1. y1 is again minus 1 plus x3. x3 is minus 3. As it is negative, let's keep it in bracket. y1 is minus 1 minus y2 is 6. See, our replacing is over. In simple way we can replace. Very careful about the values. So we get it as half of 1 into 6 minus into minus. What is minus into minus? It's plus now. Yes, so 6 plus 5 is 11. Plus into minus is minus 4 of minus 5 minus into minus is again plus. So minus 5 plus 1 is minus 4. Plus into minus, minus 3 into minus 1 minus 6 is minus 7. So basic calculations you have to do without making any mistake. So we get it as half into 11 minus into minus plus 16 minus into minus plus 21. That is equal to half into, when you add this one, what we get? 1 plus 6, 7 plus 1, 8. 2 plus 1, 3. 3 plus 1, 4. So half into 48. Half of 48 is 24 square units. That will be the area of this particular triangle. Find the area of triangle ABC in which A 5 2, B 4 7 and C 7 minus 4. So here also let's write the variables such as x1 y1, x2 y2, x3 y3. Now recall the formula for area of triangle, which is half into x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. Replace the values carefully. We get that's equal to half x1 is 5 of y2 minus y3, that is 7 minus 4 plus x2 4 of y3 minus y1 is minus 4 minus 2 plus x3, that is 7 into y1 minus y2, 2 minus 7. So replacing is over. Now the basic calculations you have to do. 5 into 7 minus into minus plus 4 plus 4 into minus 4 minus 2 is minus 6 plus 7 into 2 minus 7 is minus 5. That's equal half of 5 into 11, 55, plus into minus, minus 4 6 24. Here also plus into minus, minus 7 5s 35, which is half into 55 minus 24 minus 35. What will be the answer? Which is 55 minus 59, that is half into negative 4. Half of minus 4 is minus 2. We got area as minus 2, and we know that area is a quantity which never be negative. So take the numerical value of minus 2. So area is 2 square units. Actually, this is formed by taking a term known as absolute value or modulus, but that is not required for us here. So just do a revision work, as 3 questions are mentioned here. Just note down these questions in the paper, in notebook, and find the corresponding area of triangles. Thank you.